I'll look when we're done. Remind me. Okay, so guys, listen. Let's just a few reminders as you're getting ready. Your notes should be out. You should be paying attention to me. It's all about me. The quiz is due when? Thursday, which is tomorrow. At what time? Like 11:45. I mean, I just kind of say midnight, but Gary, go put your phone up, sweetie. Gary, your phone. Universal sign of someone on their phone. As a teacher, we learn this in teacher school. Okay, so don't forget. So what happens is we wait till the last minute, and then we're like, oh my gosh, this happened or that happened, or you're absent tomorrow, and that last reminder I give you, like if the quiz is due tonight, you don't get that last reminder. So just, guys, think of what you need to do to make sure you don't forget about your quiz, okay? Remember, I gave you a work day yesterday. You could have worked on it in class, and it's fine if you didn't, but just make sure you find time to get it done, okay? And then we had a homework check yesterday. I have given you guys a date for the test. I was going to go through 2.8. I'm going up through 2.7. So it's still 2 weeks away, just kind of giving you a heads up of when it's coming. Tests are 2 days, calculator day, non-calculator day, all of that, okay? So I keep getting great feedback about this unit. It's just been a lot easier, I think, so far than Unit 1. Unit 1 was hardcore, I felt like. It was pretty tough. But I'm hoping you guys are feeling like your Algebra 2 vibes in a lot of what we're doing, and today is definitely no exception, okay? So what this section is all about is exponential functions, which is what we've been working with, and the manipulation of them. Just how we can change the parent function and how that looks in a graph, how it affects asymptotes and all kinds of things. So these properties of exponents here that are written for you, this is a review, okay? We should know, like this one and this one, the official name isn't the distributive property of like exponents, but you can kind of think of it like that. We know that parentheses mean include everything in the parentheses, right? So if you have a power on the outside, you can rewrite it giving the power to each of them separately instead of inclusively like that. And this goes to numbers too. If there was a number in front of A, like 2, then the power would go to the 2. Anything in parentheses, whether it's multiplied in there or divided, gets that power. So the numerator and the denominator would get that power in this situation. Okay? And then if there was something in front of the parentheses, it would not get that power. Okay? Another one, this is the power property. When you have one base, 2 powers, we multiply. So like you see these all the time, like x to the third to the second, you would multiply. Okay? So power to a power, we multiply. This one, another really common one, you have like bases. Remember, base is the number or letter that has a power. When the bases are the same, we add our exponents. Keep your base, add your exponents. How about FOILing? When you do x times x, you think, oh, that's a 1, that's a 1. When I multiply x times x, I get x squared. Okay? These two we've talked about just the last few days. Remember my right over left hug somebody. You guys talked about top dog in the house or whatever you guys were talking about. But being able to rewrite a fraction exponent as Levi, pay attention. You're distracting me. So if you're distracting me, I know you're distracted. That's b to the first power, the k root of b to the first power. And then this is a really important one for you guys to understand. I'm going to talk about this. We've talked about it a little bit already, but remember, if you have a fraction bar, or if you want to move anything from top to bottom or bottom to top, so understand it's a two-way street. We can have something on top that we move to the bottom. We have something on the bottom that we move to the top. What happens is the exponent sign changes, okay? So if it's positive, it changes to negative. If it's negative, it changes to positive. It doesn't matter, okay? So what I want you guys to remember is if you cross a fraction bar, you're allowed to. You just have to change the sign of that exponent, not the base. Okay? It doesn't make the base negative. It makes the power negative. We'll see it again today. All right? So these properties of exponents are ones we kind of use all the time, and we don't really talk about them being properties. It's just like the rules that we work with. And one thing we're going to kind of have to be able to do is work backwards. Like if I have something written like this, can I rewrite it like this? If I have something like this, can I rewrite it like this? This is one we're going to see in a few minutes in an example. Given this, can I rewrite it like this? And so I'll show you that. Okay, so this first example is evaluating to 3 decimal places. The minute you see that it's got decimals in it, you know this is a calculator problem. So take a second and plug these into your calculator and practice getting the right answer. I'm giving you the answers. You're putting them in your calculator and making sure you get the same answers. Remember, these 2 squiggly lines mean approximately. Do I mark off if you don't use it? Nope. But I'm a professional math teacher, so I have to use it. Rounding to 3 decimal places. Rounding is super important, guys. On my tests, on the AP exam, you don't want to lose points because you didn't round correctly. So if that's something that you traditionally have problems with, please really take note of what you're doing wrong in the homework, so when it gets to the test, you're not still doing it. And if you need help, ask me. I will happily do a little lesson with you, one-on-one. Okay. Good? Anybody have any problems with those? Okay. All right. Review of characteristics of the parent function of an exponential function, right? B to the power of x. So this is review. So let's just go through what we already know, and then we're going to apply some new stuff to it. The domain of the parent function is all real numbers, right? We can plug any number we want in for x. A negative, a positive, a fraction, a decimal. Doesn't matter. Anything you want, as long as it's not imaginary, can be plugged in for x, right? The range of our parent function is all the positive real numbers, right? We've been saying from 0 to infinity. So that's really just the positive numbers, right? Anything above 0 is a positive number. The graphs pass through this point. That's your y-intercept, right? Also known as the a value. So the y-intercept is 1. And then we've seen it change, right? When the different number goes in front of b, changes your y-intercept, okay? Also, if b is greater than 1, it means that we have an increasing function that is continuous and concave up. I'll go over what those look like in a picture in a second. And then we have b between 0 and 1, meaning it's still positive, but it's less than 1, 1/2, 3/4, all those. That is a decreasing function that's continuous and concave up. We'll see those side by side in this first example. Our parent function approaches but does not cross the x-axis, right? The x-axis is our horizontal asymptote. Y equals 0 is your horizontal asymptote, right? That horizontal line that stops you from going into the negative numbers. Okay? And number 6 is not something we're going to talk about right now. Okay, so what we're going to do on this graph is graph 2 functions together, and we're going to talk about the relationship between them. So listen to my little speech about graphing, okay? So this goes for notes, the homework. Unless you are specifically told to do it one way, there's a lot of different ways you can graph, okay? Like by hand is to make an XY chart and plug and chug. Pick numbers, plug them in, graph them. Do I need more points to make my picture? I don't know. Let's see. Another way is to do it in our calculator, right? We could plug this into our graphing calculator, and I'm going to show you both. So when it comes time for the homework, it's really up to you what you do. On a test, it would say, like, show an XY chart or something. Because what I want you guys to know is that when you take the SAT or the ACT or some kind of test like that, and you have to, like, graph something or pick a graph or something, you know, we have lots of, like, cutesy, fancy ways of knowing how to graph things. Like a line is a great example, slope-intercept form. You graph your B, and then you do your slope from there. You only need 2 points. You connect it, whatever. But really, if you didn't remember slope-intercept form, or you didn't know what this graph was going to look like, make an XY chart. It's a great fallback method, okay? And we typically choose these 5 values because they're nice and easy numbers. We get a little bit of negative, a little bit of positive. They're right in the middle of the graph. Sometimes these numbers aren't good. Like if it was a square root graph, like the square root of x, we wouldn't pick negative numbers, and we might pick like perfect squares. So, but this is a great starting point for any graph, all right? So when I plug 2 to the power of negative 2 in my brain, it just makes it 1, 4. Remember, it moves that 2 to the denominator. So 2 squared is 4, but since it's negative, it goes to the denominator. Same here. That's 1/2, 1, 2, and 4. Okay? So it's not hard to come up with by hand to show the work if you have to. Let's go ahead and sketch that graph. Now, remember I said sometimes you might need more points? I mean, not mandatory, but I would probably go 1 more. So 2 to the third power is 8. So I could really see that curve. That just kind of completed the picture a little better for me, okay? And you recognize it as these exponential functions we're using graphing. The x-axis is my asymptote, right? I'm getting really close to it, but I won't cross it. It's concave up. It's continuous, meaning it's all connected. Smooth curve goes on forever and ever in both directions of our domain. And increasing, right? As I go left to right, my points, my y values are getting bigger. Just like a graph of a line with a positive slope, increasing, okay? Now, I could do the same thing for the g of x, all right? I could do what I just did for the g of x, but I'm going to show you something really cool about this. I'm going to apply this property to this fraction. So I'm going to say, all right, I don't want to work with a fraction. I have a way of moving that 2 out of the denominator up to the numerator, okay? So the 1 is right there. That 1 is just not doing anything. Leave him alone, right? He's just sitting there. The 2 is going to join the 1. But when I bring the 2 to the first power up, it makes it a negative 1. And then all of this, oh, and then that 2, there's an x on the outside. Let's put it like this. There's that x on the outside. When I simplify this, I don't need to write the 1. I guess you could, but we don't need to. And then this is a power to a power, so it becomes negative x. So if you look, really, this and this are almost identical. The only difference is the x has a negative in front of it, okay? And what that means, and we're going to go over those transformation rules in a second, is when x is negative, it's a flip over the y-axis, okay? It's a flip over the y-axis. So just knowing that, I don't really need to go into my calculator. I don't really need to hand write this. I just know y is my axis of symmetry, basically. So any points that are on the right are going to go the same distance to the left, and any points that are on the left are going to go the same distance on the right. So you can just kind of go through this. You can look at the points. You can look at the chart you already have. I just think it's easiest to look at the points. I'm to the left 2 up a little bit, so I'm going to be right 2 up a little bit. I have a point that's to the left 1 up a little bit. I'm going to go to the right 1 up a little bit. You can never flip over your axis of symmetry, so that point that's on the y-axis is still there. That makes sense, right? 1 is still my y-intercept. I have a point at 1, 2, so I'm going to have a point at negative 1, 2. And so on. Negative 2, 4, and negative 3, 8. And what happens is, you can see it much better once you connect the dots, how we just flipped over the y-axis. Okay? The green graph is decreasing. As I go from left to right, my y values are getting smaller, decreasing, just like a line with a negative slope. It's still continuous. It's still concave up. They have the same asymptote. They have the same y-intercept. And just to make sure you guys understand it, if I go in my calculator, and I type in 2 to the power of x, I just want to show you this. I mean, you can graph it, but the graph is just going to tell us, okay, it looks like my red graph there. That's the thing. But I really want what? What do I want from this calculator that would have helped me here? I want the table of values, right? So I would hit second graph, so I get my table, and you can see there's all my points. negative 2.25. That's the same as 1/4. And you could have written it as a decimal. There's no rule that says those have to be fractions. Okay? And so you can see your XY chart there. Then if I type in, I could type it in as 1/2 x or 2 to the power of negative x and graph it. You can see there's my green graph. Okay? And if I wanted to see its table, it's over here. There's my y sub 2. They have the same x's. The first graph, mine is red. Second graph, blue. And you can see there's the other points. And the numbers get, let me go. Right, so negative 2, 4, and so on. Negative 3, 8. You can see all the points there. So whether you do in your calculator, make an XY chart, or make one XY chart for your parent function and then move them, there's lots of different ways to graph. What I want you guys to be able to say is, and this is new, but you eventually be able to go from this to this, or I'm sorry, this to this pretty easily, and know what the asymptote is. Be able to pull out the y-intercept, things like that. Okay. Also, go to the next page or last page. This whole more than top half of the paper goes over all the transformations. Everything in the first two columns you've seen in this class already, and in lots of classes in the past. H and K and A and stretches and shrinks and flips and all that stuff. Okay, so let's just go through these really quickly, and then you can see in the last column is what it looks like in our parent function of b to the x. Right, that's the function we're talking about right now. Sometimes we do quadratic, sometimes we do absolute value. It just doesn't matter, but all the transformations mean the same thing. So vertical, up or down, right? It's the number all the way at the end, not in parentheses or anything. It's the last number. Positive goes up, minus or negative goes down, right? We know that. And I've told you before, horizontal, also known as H, is always somewhere special. It's in parentheses or absolute value symbols, under a radical, up in the air. No matter what, your vertical, your horizontal movement is hanging out with the X, always. Somewhere special. They're off by themselves. So this is minus 3 and plus 6 up with the X. That's your horizontal translation. Don't forget, that's the one that's tricky. You gotta remember it's opposite. So minus 3 is to the right, plus 6 to the left. Okay? If a number is out in front, that's our y-intercept, but it's also how the graph stretches or shrinks vertically. Okay? It affects the y value. This is the newest one, probably the hardest one, and that's when you have a number hanging out with x. So the negative in there, we just saw that. We'll talk about that in a second. But when there's a number hanging out with the x, it can move you left or right, it can flip you over the y-axis, and it can stretch or shrink your graph horizontally. So that's probably the newest one, the trickiest one. It trips me up sometimes too, to be honest. And then the reflection or flip, if there's a negative right after the equal sign, that's across the x-axis, right? Remember your happy parabola, flip it over, it makes a sad parabola. Done. Try to stay awake. And then if there's a negative up in the air, we just saw that, how it flips it over the y-axis. Okay? So someone asked me earlier today, do I have to memorize these? And I'm like, yeah, but you kind of already have most of them memorized. Really outside of this one, most of these are probably in your brain, okay? And you're going to see some of that here. One of these will affect your horizontal asymptote. One of them. Which one of these transformations affects your asymptote? It's going to change it from y equals 0 to something else. Who knows? It's for a really cool sticker. I'll bribe you. Vertical translation. Yeah, not just any translation. Good job, Sabine. You're going to get a really cool sticker. It's a vertical translation. Think about why. If you move your points up or down, that's going to move your asymptote up or down. Okay? So the K gives us our asymptote. So K affects the HA. You'll even see in some notes and books and stuff, the horizontal asymptote is always described as y equals K. So it's been 0 all along because there's no K value. K has been 0. But if I put a plus 3 there, my horizontal asymptote is going to be y equals 3. It moves all my points up. Okay? And you'll see that in the homework. All right, last problem. These all go together right here. We're going to graph 3 to the x over here and then 3 to the x plus 3. So by hand, in your calculator, however you want to do this, when I do 3 to the negative 2, it puts the 3 in the denominator, so you get 1/9, 1/3. Anything to 0 power is 1, 3, 9. I would just say you want to know how to do it both ways. Be able to plug numbers in and get the right answers, or put in your calculator. And if I took the time to plug this into my calculator, when I look at the table, you get like 0.11111 here instead of 1/9. That's okay. 0.1, what's the difference? It's a teeny tiny number, right? 0.1 and 1/9, who cares? Okay, so you could have written them as decimals if you were using your calculator. So let's go ahead and quickly sketch that. I don't mean quickly. We're not in a rush. You're going to finish your homework probably. I think we all know how to plot points. Makes a very typical exponential looking graph, right? There's no k value. I mean, you could call it +0 out there, right? But that makes our asymptote the x-axis. And I could plug these x values in here. And let me just do that so for you. If I put a -2 there, I get 0. Anything to 0 power is 1. And just, I did the math already. So I could plug numbers in there. I could put it in my calculator. Or I could say, what is that +2 going to do to all of my points? What direction does the +2 move all my points in? Yes, that means left 2. So when I move points left 2, it's not going to change my asymptote, but it's going to change some other things. So I could have just done that. I could have taken some of these points and moved them to the left 2. I could have plugged in. I could put in my calculator. There's lots of different ways. Just know that you have lots of options. So go ahead and sketch this graph. And really, there's only 3 points that fit on the graph. That's 2, 9, 3. You use the same x's. Yeah. So when you plug a 2 here, 2 plus 2 is 4, and 3 to the 4th power is 81. Okay? Okay. No. I just feel like I messed something up here. 1, 3. Oh, 0, 9. That's that point. Forget that point right there. Sorry. And then the other 2 points go way off. That's okay. We don't need to graph them. We see the shape. We know the points continue up forever. And if you look, these are all to the left 2. Left 2. All of them. Okay? And that would happen forever and ever and ever, all the points. Left 2. So lots of different ways to get to that conclusion. But in our last problem, I want to make this connection for you. She said, that's me, she said that A is my y-intercept. So what's the A value here? Isn't it 1? But in my second graph, my purple graph, my y-intercept was 9. I went from a y-intercept of 0, 1 to 0, 9. Here's why. What we're going to do is rewrite this in reverse, kind of, with our exponent rules on the first page. And we're going to call it a new function called h of x. So I'm going to go back and say, okay, 3 to the x plus 2, that's this guy. Remember I told you we're going to use that again? So before it was b to the m plus n, it looked like this. So I would say, okay, I can split that base into 2, same bases, and then split up my sum of powers. Now, you're not used to going in reverse, and mistakes can happen. So what I always say is, after I write it, I work in reverse. If I was given this, what would it look like if I combined them? Okay, so I have like bases. I would keep my base, add my exponents. So I could easily see how this would go to this, so it works in the other direction. Now, let's clean it up a little bit more. I can simplify 3 to the 2nd power. That's 9. And then I have a b value of 3. There's my parent function, 3 to the x. What this 9 means is I have a y-intercept of 9. Yep, we already just talked about that. It's stretching my graph vertically by a factor of 9. It happens naturally in our points. We don't actually physically do it. But this new h of x is the same as that. And I think that's pretty cool to be able to apply those properties. So when you throw some transformations in, like this plus 2, it changes your a value. Okay, you can't just go with, oh, my graph is going to cross at 1, and I just proved to you why. Okay, because when we stretch it, it changes where your graph hits the y-axis. And there it is mathematically. Do you think that's kind of cool? Or am I just doing it? Okay. All right, so let's see what the homework is. Let's go to practice set 1, practice set 1, practice set 1. And we're just doing 1 through 13. So write this down. Okay. And so 1 through 4 is just putting in your calculator, rounding correctly. 5 through 8, what transformations happen from parent function to the transform graph, just saying it in words. And then the last few are graphing. Okay? And I don't care if you do it by hand, on the calculator, but make sure you are able to do this.